The National Electrical Code, or NEC, is a comprehensive set of standards for electrical wiring and equipment in the United States. It's designed to ensure electrical safety and prevent hazards such as fires and electrical shocks. The NEC is updated every 3 years by the National Fire Protection Association, or NFPA, and is essential for electricians, engineers, and anyone working with electrical systems to be familiar with its requirement. The question of whether the 2002 NEC contains any provisions that allow the use of only one conductor on a circuit breaker is an important one for ensuring code compliance and safety. Circuit breakers are protective devices designed to interrupt the flow of current in the event of an overload or short circuit. They are a critical component of electrical systems, protecting equipment and preventing electrical fires. Typically, circuit breakers are designed to have conductors connected to both the line and load sides, completing the circuit. The practice of connecting only one conductor to a circuit breaker is generally not permitted by the NEC, as it can create imbalances in the electrical system and potentially overload the breaker. This is because circuit breakers are designed to operate with a balanced load on each pole. Using only one conductor can lead to an unequal distribution of current, which may cause the breaker to trip prematurely or, in more severe cases, overheat and fail. The NEC provides detailed guidelines on how to properly connect conductors to circuit breakers to ensure safe and reliable operation. These guidelines cover topics such as conductor sizing, insulation types, and termination methods. It is crucial to follow these guidelines to maintain the integrity of the electrical system and prevent hazards. Firstly, the NEC specifies that conductors must be properly sized for the load they are intended to carry. This means selecting conductors with an ampacity rating sufficient to handle the expected current flow. Secondly, the NEC requires that conductors be properly insulated to prevent electrical shock and short circuits. The type of insulation must be appropriate for the voltage and temperature conditions of the application. Thirdly, the NEC outlines specific requirements for terminating conductors at circuit breakers. These requirements cover topics such as torque specifications for terminal screws and the use of appropriate connectors. Failing to properly terminate conductors can lead to loose connections, which can cause overheating and arcing. When installing circuit breakers, it is essential to follow the manufacturer's instructions and the requirements of the NEC. This includes ensuring that the breaker is properly rated for the circuit it is protecting and that it is installed in a suitable enclosure. It is also important to test the breaker after installation to verify that it is functioning correctly. The 2002 NEC, like other editions, emphasizes the importance of balanced loading in electrical systems. Balanced loading helps to ensure that current is evenly distributed throughout the system, preventing overloads and voltage imbalances. When using multi-wire branch circuits, for example, the NEC requires that the neutral conductor be sized to carry the maximum unbalanced load. This helps to prevent the neutral conductor from overheating and causing a fire. In general, it is not permissible to connect only one conductor to a circuit breaker unless specifically permitted by the manufacturer's instructions and the NEC. Such exceptions are rare and typically limited to specific types of equipment or applications. If there is any doubt about whether a particular wiring configuration is permitted, it is always best to consult with a qualified electrical inspector or engineer. They can provide guidance on the applicable requirements of the NEC and help ensure that the installation is safe and code compliant. The NEC also addresses the issue of using circuit breakers in series. This practice, known as series-connected circuit breakers, involves connecting 2 or more breakers in series to provide additional protection against overcurrents. While series-connected breakers can be used in certain applications, they must be carefully coordinated to ensure that they function properly. The NEC provides specific guidelines on how to coordinate series-connected breakers to prevent nuisance tripping and ensure that the system is adequately protected. Furthermore, the NEC addresses the use of ground fault circuit interrupters, or GFCIs. GFCIs are devices that are designed to protect people from electrical shock by detecting ground faults. They are required in many locations, such as bathrooms, kitchens, and outdoor areas, where there is a high risk of electrical shock. The NEC specifies the requirements for installing and testing GFCIs to ensure that they are functioning properly. In addition to the specific requirements for circuit breakers, the NEC also contains general requirements for electrical safety. These requirements cover topics such as grounding, bonding, and overcurrent protection. It is essential to follow these general requirements to ensure that the electrical system is safe and reliable. Grounding is the process of connecting the electrical system to the earth. This helps to provide a low impedance path for fault currents, which can help to prevent electrical shock and equipment damage. The NEC specifies the requirements for grounding electrical systems, including the size and type of grounding conductors. Bonding is the process of connecting together all of the metal parts of the electrical system. This helps to create a low impedance path for fault currents and reduce the risk of electrical shock. The NEC specifies the requirements for bonding electrical systems, including the types of bonding connectors that are permitted. Overcurrent protection is the process of protecting electrical circuits from overloads and short circuits. This is typically accomplished by using circuit breakers or fuses. The NEC specifies the requirements for overcurrent protection, including the size and type of overcurrent devices that are required. The NEC also addresses the issue of using arc fault circuit interrupters, or FSIs. FSIs are devices that are designed to protect against fires caused by arcing faults. They are required in many locations, such as bedrooms, to help prevent electrical fires. The NEC specifies the requirements for installing and testing FSIs to ensure that they are functioning properly. Moreover, the NEC provides guidance on the proper use of flexible cords and cables. Flexible cords and cables are often used to connect portable appliances and equipment to electrical outlets. The NEC specifies the types of flexible cords and cables that are permitted for various applications, as well as the requirements for their installation and use. In addition, the NEC addresses the issue of using surge protective devices, or SPDs. SPD are devices that are designed to protect electrical equipment from voltage surges caused by lightning or other events. The NEC specifies the requirements for installing and testing SPD to ensure that they are functioning properly. The NEC also provides guidance on the proper use of electrical boxes and enclosures. Electrical boxes and enclosures are used to protect electrical wiring and devices from physical damage and environmental conditions. The NEC specifies the types of electrical boxes and enclosures that are permitted for various applications, as well as the requirements for their installation and use. Furthermore, the NEC addresses the issue of using transformers in electrical systems. Transformers are used to change voltage levels in electrical systems. The NEC specifies the requirements for installing and using transformers, including the need for overcurrent protection and proper grounding. It's crucial to remember that electrical work can be dangerous, and it is always best to consult with a qualified electrician or engineer before undertaking any electrical project. They can provide guidance on the applicable requirements of the NEC and help ensure that the installation is safe and code compliant. In summary, the 2002 NEC does not contain provisions that generally allow the use of only one conductor on the circuit breaker. This practice is typically prohibited due to the potential for imbalances in the electrical system and the risk of overloading the breaker. It is essential to follow the NEC guidelines and manufacturer's instructions when installing circuit breakers to ensure safe and reliable operation. Always consult with a qualified electrical professional if you have any questions or concerns about electrical wiring practices.